afternoon friends. So in this session we are going to learn Elgamal public crypto system. Previous session we have seen how we do DeFi-Hellman key exchange. Okay. So now for the Elgamal public crypto system you require a queue which is a prime number. Okay. You require a queue which is a prime number which will be provided to you in the problem. Okay. So you require a queue which is a prime number and such that and you require a value called as alpha. In your alpha value should be chosen such that GCD of alpha comma q should be always equal to 1. Okay, so alpha value will also be provided to you and this q value will be also provided to you. Okay, so now let us go to our step number 1. In step number 1, let us see key generation done by A. Okay, so definitely the private key will be named as XA, the same way what we have seen in the previous algorithm. So A will choose a private key XA such that XA should be less than Q minus 1. Okay, so A is choosing a private key XA such that it should be equal to Q minus 1, and using that private key he is generating the public key called as YA. So the same formula that we used in the previous algorithm. So YA will be nothing but alpha raised to XA. Alpha will be the value that is provided and XA is nothing but what? XA is your public key. Okay, XA is your private key which is chosen by A. Okay, so he calculates what is the public key using the private key. So what will be known to the user now? What will be the public key? Q. Q will be known to all the users, alpha will be known to all the users and YA will be known to all the users. This is nothing but your public key of A. Okay, this is nothing but the public key of A. Okay, so it will be known to all of you. What will be not known, that will be private. That private is nothing but XA, that is the value of that we have chosen. Okay, now A will send this, now this A is going to send this public key. Okay, so A is going to send the public key to B. Okay, he is going to share it. He is going to share it or he is going to send it to B. Okay, now B will do, now B should send something to A. So what he will do, B will do encryption using A's public key. Okay, so B wants to send something to A, so B will do encryption as we have seen previously. If B wants to do encryption, what is public about A to B is nothing but the public key of A. So encryption of B, encryption will be done by B using A's public key. Okay, now for that to do encryption we require a plain text. Simply with the key we cannot do, we need to send some information. That information is nothing but plain text which is taken in the form of M. Okay, and that plain text should be always less than Q. Plain text should be always less than Q. Okay, the second thing that is required is a random integer K. Now why do we require this random integer K? Is nothing but this K will act as a key. Okay, this K will act as a key. Okay, we will have two values of K. There is one value of K and one value of K1. Okay, so we are making this algorithm more robust by using two keys, K and K1, and again we will be having ciphertext C1 and C2, because C1 we will be finding out using our key K and C2 we will be finding out using our key K1. Okay, so we have chosen a random integer K. Okay, so in this step we know what is our plain text M. We have chosen which our random integer K. Okay, such that K should also be less than equal to, so both of these should be less than equal to Q. Okay, the main value that is provided to you. Q is nothing but a prime number that is provided. Okay, now we will calculate what is K1. Okay, one more key. So what is the formula to K1? K1 is using the public key of A raised to K, that the value that we have chosen, mod of Q. Okay, so over here what is very important is you need to keep the formulas in mind. Okay, so once we calculate the K1, we will calculate what is the C1 and C2. So in this case, we will calculate two ciphertexts now, C1 and C2. Okay, so C1 will be nothing but alpha, the value that is provided to you. Okay, plus raised to K. Okay, raised to K is nothing but the value that we are choosing. Okay, the Bob will be choosing the B, the part B. The user B will be choosing the value of K, mod of U. Similarly, what we will do now? Similarly, we will also find out what is our ciphertext C2 to make it more robust. So C2 will be nothing but your K1. Okay, K1 is the key that we have just generated previously. So this K1 is nothing but the key that we have generated over here using the public key of A. Okay, and the plain text M mod of Q. Okay, so now we know that the ciphertext contains two ciphertexts C1 and C2. Now B has already sent the message, okay, to A, okay, using the above formulas. Okay, now A will have to decrypt it. Okay, A will have to decrypt it. So how A will decrypt it now? A does not require any private key or public key of anybody else. So A is going to decrypt using his own public key. Okay, his own public key. What is A's public key? A's public key is nothing but XA. So whatever he has chosen, XA value that will be given to you, using that you are going to do the decryption. Okay, so he has the ciphertext with him, that is C1 and C2. So first he will find out what is K1, the key that is required. He doesn't even want to find out what is K, but The moment you find out K1, so K1 is nothing but formula C1. C1 will be given to you. XA is nothing but the private key of A. A will be already having with it, okay, and mod of Q. So by doing this, he will get what is the value of K1. Now he needs what is the plain text. Now this plain text will be, formula will be exactly opposite to this C2, because here we are having plain text, no? Now we have to make some arrangements in such a way that you can find out what is your plain text. So plain text will be nothing but C2. C2 is nothing but this value, okay? And when we take K1 onto the left hand side, what it will become? It will become K1 inverse mod of Q. Okay, so my plain text will be nothing but exactly similar to the C2. C2 is nothing but the ciphertext that is generated over top. Okay, so you have to keep these formulas in mind. Okay, so these formulas are very, very important. Okay, using these formulas, we will solve one problem. Okay, so that we can find out what is the answer. Okay, so we will take down one problem, we will solve using the same algorithm. Okay, now this is a different type of problem, okay, where value of Q is given to you as 11. Okay, so this value of Q is given as 11, value of alpha is given as 7, value of Y already given to you, don't even need to calculate what is Y as 2, K value is given to you as 4, and M value is given to you as 5. M is nothing but the plain text, and it is told to you to determine only the ciphertext. So in this problem we will determine only the ciphertext. In the further problems which I will be giving you as a homework problem, you will have to find out the plain ciphertext as well as the plain text. So let us see the formulas which are used. Okay, so let us see the formulas which are used. So now we don't, as a step number 1, we don't need to calculate this, correct? Because Y value is already provided to us. So we will directly go towards the encryption part, because they told us to find out only the ciphertext. Now in the encryption part, the first formula is nothing but this. Okay, this is your first formula to calculate K1. Okay, so how do I calculate K1? So K1 is nothing but, K1 formula is nothing but YA raised to K, YA raised to K, okay, mod of Q, YA raised to K, mod of Q. Okay, YA value is already provided to us, YA value is 2, K value is given to us as 4, okay, mod of Q is nothing but a mod of 11. Okay, so 2 raised to 4 is nothing but 16, 2 raised to 4 is 16, 16 mod of 11 is nothing but, 16 mod of 11 will be equal to 5. Okay, 16 mod of 11 will be equal to 5. So we have got the K1 value as 5. Okay, now we need to find out what is the value of C1. Okay, to find out what is the value of C1, what we are going to do to find out the value of C1. Okay, so C1 is nothing but alpha raised to K, mod of Q. Okay, alpha raised to K, mod of Q. Okay, so this is nothing but this formula that we are taking. Okay, so formula number 2. Okay, alpha raised to K. The alpha value is provided to you as, alpha value is already given to you as 7, right? The alpha value is already given to you as 7. So 7 raised to K. K value is given over here as 4. Okay, 7 raised to 4 mod of Q. Mod of Q is nothing but mod of 11. Let us calculate what is 7 raised to 4 mod. Okay, so when we calculate 7 raised to 4, we get the value of 7 raised to 4 as 2401 mod of 11, which is nothing but 3. So we have calculated what is C1. Now what is been told to us, only told to us to find out what is the ciphertext. So we need to calculate what is C2. Okay, so now C2 formula is nothing but, C2 is nothing but K1 into M, K1 into M, okay, mod of Q, K1 into M, mod of Q. Okay, so what is K1? K1 is the value that we have calculated, it is nothing but 5. Okay, that 5 into M is nothing but also 5, the plain text that we have taken on top 5, and mod of Q. So mod of Q is nothing but mod of Q, Q is nothing but 11. Okay, 5 5s are 25. Okay, 25 mod of 11. 25 mod of 11 is nothing but, okay, 25 mod of 11 is nothing but 3. Okay, so 25 mod of 11 is, okay, again 3. So the ciphertext that we have calculated over here is nothing but C1 comma C2, which is nothing but 3 comma 3. Okay, now in this problem it is only asked to you to solve calculate the ciphertext, but the other problems that we are going to see it will be in a different form. Either it will be told to you to find out the encryption as well as decryption, or only the decryption part. Okay, so you need to keep in mind the formulas, okay, for Elgamal public key crypto system. Okay, so first is the key generation by A, that is the public key and private key. Then B wants to send something to A, so he will encrypt the data using A's public key. There he will calculate what is K1, okay, what is C1 and C2. And then for the decryption part, A will use its own private key. Okay, so A will use its own private key to find out what is the solution. So he will first find out what is K1, okay, and then he will find out what is the plain text M. Okay, So whatever plain text you have which was sent by B, the same plain text will be received over here. So we will solve more problems on this, okay, because Elgamal crypto system and Diffie-Hellman key exchange are sure shot question in your question paper, either in part B or in part C. They are repeated most of the time in almost all the paper. There is one problem Diffie-Hellman key exchange and one problem of Elgamal public key crypto system. Okay, so please revise both this concept properly. Please learn both the formula. So there is nothing great in this. You just need to know the formula, substitute the values in the formula and get the answer. Okay, so that is all for this session. In the next session we are going to continue with discrete logarithm, okay, and then how to use the discrete logarithm to find out Pauling-Hellman algorithm. Okay, thank you.